We've done simplifying, adding, subtracting, multiplying, and now we're on to dividing radicals. All right, so we've got this quotient property, and all it basically says is if you're dividing this fraction, you can break it up as the nth root of a over the nth root of b. So it's basically just saying you can divide those two radicals and still take the root of each of them. All right, so we kind of hit the simplest form last week, but we didn't really tackle 2 and 3. The radicand has no factors that have a power greater than the index. So again, the index is the number out here, and the radicand is the number inside. So these powers have to be smaller than the index, and we've been practicing that quite a bit. And then 2 and 3, like I said, we wrote them down in our notes last week, but we didn't really tackle them. You cannot have any fractions under the radical, so no fractions, and no radicals in the denominator. Okay. So there's a couple different ways this can look, and we'll just kind of tackle all the examples and then practice a little bit of all of them here. So question A, 2 over root 3 breaks rule 3. Okay, no radicals in the denominator. All right, so here's how we tackle it. We just literally multiply by itself. We're going to multiply by root 3 to the top and the bottom. Okay, so now we kind of go with our multiplication rule. When I multiply fractions, we go across the top. Outside stay together, inside stay together. So that's just 2 root 3. Now here's the point of doing this. What's radical 3 times radical 3? Radical 9, which is really just 3. So you can put radical 9 if you want, but then you still have to reduce it to 3. And now you've eliminated the radical in the denominator. Okay, so if you multiply a radical by itself, remember, you just get that number under there, and that's kind of the whole point. We want to get rid of that radical in the denominator. All right. So B is very similar. I can just follow this original rule where I can separate the radicals. So I'm going to say it's the root of 7 over the root of 8. Okay, so now I'm still breaking rule 3. What would I want to multiply the top and bottom by? Radical 8. So multiply the top and bottom by radical 8. So these are both inside, so I'm going to get 8 times 7 is 56. Square root of 8 times the square root of 8 is really the square root of 64, which is really just 8. And then if I can simplify, I need to. I'm guessing I can break 56 down. Does 4 go in there? That's a perfect square. 4 times, I'm getting rusty this morning. It's been a really rough morning. 14 times? All right, so I'm going to say that's radical 4 and radical 14, which is really going to become 2 radical 14 over 8. And then the 2 and the 8 can divide and reduce to 1/4. Okay. So I've kind of tried to break them up into partners. So those two are very similar. I'm going to kind of put a line under there. That's when you have that radical in the denominator. So I'm going to say this is rule 3. All right, no radicals in the denominator. Now, questions 1 and 2 are very similar, but now instead of square roots, they are cubed roots. So I can say this is the cubed root of 8 over the cubed root of 27. Now this one's actually really nice. Do we know the cubed root of 8? 2. Do we know the cubed root of 27? 3. So that reduces real nicely. That wasn't super exciting. All right, let's try the next one. So I can break this up as the cubed root of 16x to the 4th. Yes. Oh, how did that happen? All right, the cubed root of y to the 9. Thank you. Okay, so again, we're just breaking them up. Now, this one's a tad bit uglier because do I know the cubed root of 16? So I got to break it down. What's a perfect cube that goes into 16? Good, 8. So I can say it's the cubed root of 8 times the cubed root of 2. All right, now how about my x to the 4th? I need a cubed root of x to the what? Cubed, and then just an x. And that's the simplifying we've done for the past couple of days. And then I can leave cube root of y to the 9th because obviously 3 goes into 9. All right, so now we'll just simplify what we know. We know the cubed root of 8 is 2. I know the cubed root of x cubed becomes x, and then those guys get left in the cubed root, 2 and x. Their powers are smaller than the index, so that works. And then the cubed root of y to the 9th just becomes y to the 3rd. Okay, so that's just the simplifying that we've been doing. All right, and I'm going to kind of say that goes with rule number 3 as well, leaving no radicals in the denominator. Okay, so 3, 4, and 5 kind of just go with simplifying factors with a power greater than the index. These 3 questions have been on our recent Regents exam, so that's why I kind of specifically picked them here. Just kind of revisit on how we wrote this. We need to write this as an alternate form. This is really x to the what power? What fractional power? Not quite 1. Remember, it's going to be a fraction. Did you say 1/2? Oh, gotcha. So we did this the first day, I think, of radicals. We wrote this in an alternate form, and it has a fractional exponent. Oh, okay, so you're breaking it down, which is, I'm going in a different direction. What you're saying is not wrong. You're saying square root of x to the 4th and x. Love it. I'm just kind of leading us in a different direction, but that is 100% correct. 5 over, not 1, you're super close. 5, it's a square root, 5 over 2. So we're just going to rewrite, so this is slightly different. We're going to rewrite this as that fractional exponent. Remember, the name of the root goes in the denominator. Square root, power on top. Okay, so I have that over just x. And now when I'm dividing, what can I do with these exponents? Not cancel, but division, we subtract the exponents. So I need to do 5/2 minus 1. It's 5/2 minus 1. Three over 2, good. Okay, so I can leave this answer like this, or I can say the root goes on the bottom. This is the square root of x cubed. Okay. So again, when we have a root, we also have a fractional exponent. These are equivalent. Let's try 4. How can I rewrite this first term? X to the what power? 4 over 3 is great. Times x to the 5 over 2, so power root, and then x to the good 1 over 7, because that exponent has a 1 there. All right, so now just going through the rules. When I multiply, what am I going to do with those exponents? Add, so take a moment and add those. Either get common denominators or use your calculator. What's 4/3 plus 5/2 get us? What'd you say? And now I'm dividing. What am I going to do with these exponents? Subtract. So again, just use your calculator, subtract those exponents. X to the what? 155 over 42. Okay. So again, just kind of a little review going back to those roots versus simplifying. All right, let's try one more of that type, and then we'll get to the last type. So again, just a reminder, everybody in this set of parentheses has to get raised to the, not to the 10th. Who's all of this raised to? 1/3, yep. So I have 2x to the 3/4 stays. 8 to the 1/3, and that would be x to the, what am I doing with these two numbers? Multiplying, good, so that's 10/3. Okay. So 8 to the 1/3. So you'll see this on the spiral this week, and they're going to ask you to explain it. You should be able to say this 8 to the 1/3 becomes the cubed root of 8. And we know the cubed root of 8 is actually 2. So that just becomes a 2. And then these 2's are going to cancel out. So I really have x to the 3/4 over x to the 10/3. And when I'm dividing again, I'm just going to subtract those exponents. So take a moment and subtract your exponents. And we should get x to the Ethan, what did you get when you subtracted there? Negative 31 over 12. Okay. All right, so if I wanted to write that in root form, I'm just going to review that equivalency. The negative would turn this into a fraction. The denominator is the root, so that would be the 12th root of x to the 31st. Okay, and again, the reason it became a fraction is that negative flipped it over the fraction bar. Root goes on the bottom, so 12th root of x to the 31st. All right, so we'll see a chunk of like those to practice kind of as a little review for homework. Okay, the last part of dividing, so you'll notice in these first division problems, we only had one term on the bottom. Okay, the last part of dividing, you're going to have two terms on the bottom. Obviously, we're going to have binomials here. All right, so I want you to put a little star here, and we're going to say multiply by the conjugate. Multiply by the conjugate. Okay. So we talked about conjugates when we did factoring. There are terms that are the same, but one has a plus and one has a minus. It's like factoring perfect squares. So if this one has the plus, then I'm going to multiply by 3 minus root x. Okay, so there's terms that are alike, but one has a plus and one has a minus. All right, and now we're just going to multiply. So we're literally going back to the rule from Friday. So I'm going to distribute this one through. So 2 times 3 gets me 6. 2 times radical x is just 2 root x. Okay, so that was just distributing. Now this is a binomial times a binomial. So on this one, I do have to FOIL because it's 2 terms and 2 terms, bless you. So I'm going to FOIL this out. My first gets me 9. Then I get minus 3 root x. When I do the insides, I get plus 3 root x, which is beautiful. And then when I do the outsides, I get minus the root of x squared. So I'm just FOILing first, outer, inner, last. Now what's nice is anytime you multiply by conjugates, the middle two terms should always cancel out. So I have 6 minus 2 root x. And on the bottom, I have 9 minus, and again, the square root of x squared is really just x. Okay. So anytime there's 2 terms on the bottom, we're immediately going to say multiply by the conjugate, and then it's just a multiplication problem. So if I look at 7, I have 15 over root 5 minus 2. So in this case, I would multiply by root 5 plus 2. The top is just distributing because it's one term, so take a moment and distribute. And the bottom is a FOIL because it's 2 terms. So take a moment and multiply the top, multiply the bottom. And again, just outsides together, insides together. 15 times root 5 is just 15 root 5 plus 30. Okay. Root 5 times root 5, hopefully you can do it in your head, is root 25, which again is really just 5. Then I get plus 2 root 5 minus 2 root 5. And then negative 2 times positive 2 makes a negative 4. Okay, and that part's all review. That's what we did last week on just multiplying. So now as I clean it up, those middle terms cancel. I've got a 5 minus a 4, which is really just a 1. So I think I just get 15 root 5 plus 30. All right, so again, when I multiply, the outside goes to the outside, insides to inside, so I can't actually put those together. All right, let's try 8. So I've got a binomial. So I know I'm multiplying by the conjugate. I'm keeping the terms, just changing the middle sign. So instead of a plus, I'm now going to use a minus. And again, just carefully distribute and FOIL the bottom. Outsides go together, insides go together. Alex, what'd you get on the numerator up top there? Sounds perfect. Any questions on that part? Again, the outsides are 14 and 2 times the root 2. Distribute that. All right. So when I multiply my first on the bottom, the outside I get 4, and the inside I also get 4. So I'm just calling it 4 root 4. And I get minus 2 root 2 plus 2 root 2 minus 1. Okay, just a quick FOIL. The square root of 4 is actually the number 2. So 4 times 2 makes an 8. Those cancel. I get minus 1. So I've got 28 root 2 minus 14 all over 7. Yes, I absolutely. Yep. Okay. Now at this point in the numerator, they definitely have a GCF I could pull out. What goes into both of those? 7. So I can pull out a 7. And I'm left with 4 root 2 minus 2. So I'm just pulling out that yes. Oh, as my GCF? Absolutely. Absolutely. You could pull out 14 as well. The reason I pulled out 7 is just because I saw that those were going to cancel. If I pulled out 14, then I would just divide them to get the 2. Absolutely. Nice call. And when I pulled out that 7, those 7s would cancel. I'm going to do exactly what Al said. I'm going to pull out 14 as well. So I would get 2 root 2 minus 1 all over 7. So if I did that, these two would divide to a 2, and if I distribute that through, it's exactly what I have here. So either one totally works. Okay? Absolutely. All right. Last one to tackle there, go ahead and multiply by the conjugate. Just careful on your foiling. So it looks like you're going to have a binomial on the top and bottom, so just make sure you foil both. No, you got to pick the same thing. It's always the bottom. Oh, okay. Yeah, great question. So yeah, just to reiterate, we always want to pick the bottom because that's the one where we have to eliminate the radical from. Good question. Okay, so we're just going to use that conjugate and always of the bottom. And it's got to be the same to the top and bottom. And then carefully just foil. trinomial times a binomial. We're not distributing. We definitely have FOIL on top, FOIL on the bottom. So wait, what'd you get when you FOILed on top there? Oh, your final answer, radical 9 plus 2. All right, I like your final answer. I'm just going to go a few more steps in there for anyone that was stuck. So radical 9. Oh, maybe, hold on. I don't think those cancel on top because they're not conjugates. So be real careful. Radical 3 times radical 3 is radical 9. When I multiply these, I get plus 2 root 3. My inners get me plus 1 root 3. And then I get that plus 2. Now these aren't the conjugates, so their middle terms aren't going to cancel. It only cancels on those conjugates. So when I multiply the bottom, I get the root 9 plus 2 root 3 minus 2 root 3. That's where those are going to cancel. And then minus 4. Okay, make sure you FOIL. As I clean this up, root 9 is actually just 3. I can do 3 plus 2 to get a 5. And then root 3 and root 3 are like terms, so 2 root 3 plus 1 root 3 gets me 3 root 3. The square root of 9 again is 3, so I have 3 minus 4, so I get divided by a negative 1. Okay, now typically you're never going to leave like a negative 1 in a denominator. I'm just going to go through and divide these by negative 1. So this would be equivalent to negative 5 minus 3 root 3. I'm just going to divide them both by a negative. Okay. So kind of our last day of radicals, we've kind of hit everything we can do with them. We've simplified, added, subtracted, multiplied, and divide. So like I said, our last day of roots. Got a practice page here that kind of mirrors the questions exactly. So these first 4, bless you, follow the first couple examples, the next 3, and then the next couple follow after that. I don't know if the answers are there, so I will get them worked out and posted. I'll put them right on our Google Classroom page so you have something to compare to. But I will hopefully get that posted in the next few minutes here. But they should, like I said, match up exactly as you're going through. So that'll be our tackling for homework tonight. We're going to tackle the sheet 1 through 11. You can probably get a head start. I think we've got till 8:11 technically. So see what you can crank out. If you want to do them right on there, that's fine if you've got some room. And I'll get mine posted in a minute.